All right, this is part 2 of exercise 8F. Let's get straight into it. So example 23, we're going to be determining the payment amount, total repayment and total amount of interest paid for a reducing balance loan. Now this one's a bit of a wacky example because of what it's asking for and how to interpret the information from one of the particular values. So I'll try my best in explaining what's going on here. Now, Sifo, what a name, decides to borrow $10,000. Now this is the weird part. It's going to be repaid in 59 equal monthly payments, followed by a 60th payment of less than $1. So a certain amount that's between $0 and $1. And this value is going to be more than the regular payment. So a particular value is going to be added, which is less than $1, to the regular payment. Now, interest is charged at a rate of 8% per annum, compounding monthly. We're first going to find the regular monthly payment amount, and we're going to round this answer to the nearest cent. So let's fill in what we do know for question A. Now, what we do know from this is that he is borrowing money. So his present value right now is $10,000. And this is positive because this is money going into his pocket. It's being taken from the bank. Now, the interest rate is at 8%. And this is 8% per annum compounding monthly. So payments and our compound amounts per year is going to be 12 and 12. Now, what's happening is at the end of these final payments, he's going to be paying off the loan. So the future value is going to be at 0. And what it takes to do this is we're paying a particular amount of per month 60 times. Now, a lot of students get confused with this part because they assume that they're going to do this payment 59 times because it says 59 equal monthly payments. But the fact that it says followed by a 60th payment, that's going to be different. We are going to assume that this payment is done 60 times. And we are going to try to figure out what is that 60th payment really meant to be. So we're going to get a payment amount. We'll get a negative amount because this is now money going out of Sifo's pocket to pay down this $10,000. And what Sifo has to pay per time frame, so per month, is 202.7639. So in other words, Sifo pays $202.76. Now this here, even though we've worked it out after 60 payments, this here is going to be for 59 payments. The next and very last payment is going to be different. Now, how do we actually work this out? So for question B, let's say that Sifo pays this amount 60 times. Okay, so it pays this certain amount 60 times. So what we're going to do is we're going to work out 60 lots of $202.76. This here will give us how much he's paid off to the bank. So the $10,000 and the interest on top of that. Because the unfortunate thing about the financial solver is that it doesn't show you how much interest has been paid to the bank. It can show you anything else, but it doesn't show you that specific interest amount. So when Sifo pays 60 lots of this amount, he ends up giving the bank $12,165.60, where $2,165.60 of this is going towards interest. Now, let's say that this amount here, this $202.76 is what's being paid. We're going to put this information in again, which seems kind of counterintuitive, but you'll see why. So 60 payments at an interest rate of 8 with 12 compounds and 12 payments. And what's happening is if we're borrowing, or Sifo is borrowing $10,000 and he's making payments of $202.76. Now let's draw a comparison between this value here and this value here. These two values are almost identical, they're almost similar. This particular payment here is accurate to 4 decimal places, where this one has just been put in after we worked out what these payments need to be. And so what will happen is your future value after you've made 60 payments of this amount is going to try to compensate for the error that's occurred. So when you split this amount in, what you'll end up getting is a future value of negative 0.289. Or in other words, there is a difference of 20, if we round this, 29 cents. So the amount that CIFO has to pay back to the bank is what he usually pays, plus an additional 29 cents to compensate for that error, that little extra bit that's there. So therefore, the last payment is what he would have paid within usually, plus an additional 29 cents. So it is a bit of an annoying thing that you have to calculate just that little error that occurs, but it does specify that the 60th payment is more than the regular payment by an amount that's less than $1. Well, that amount is less than $1, it's 29 cents. This would give me a payment of $203.05. So this here is his last or final payment. Now example 23 has also questions C and D. I'm just going to make a quick page for this. Alright, question C, if you just look in your sheet, it's asking us to find the total of the repayments on the loan. We went around our answer to the nearest percent. For question C, what we are working out now, financial solvers helped us determine particular values and an error, but now we actually have to use a bit of crunch power, a bit of maths, in order for us to determine how much money is going towards this loan. So in other words, we're making 59 payments of a certain amount and one payment, which is our last payment, of a certain amount as well. So we're making 59 payments of $202.76. This is what we worked out in the first part. And then we're also paying one last payment of $203.05 because we had to compensate for the error. This will give us a total of $12,165.89. This is the proper amount that CIFO has to pay. Obviously the $10,000 and the additional $2,000 yada yada of interest. Question C is, I'll find the total amount of interest paid, and we're going to round our answer to the nearest cent. So the amount of interest is effectively the difference between how much he's paying back to the bank and how much he borrowed in the first place. The interest is equal to this amount here, take away how much he initially borrowed, which gives us an amount of $2,165.89. This is going to towards interest. All right, last example, and then you're going to tackle these set questions here. Example 24, Joe. Joe invests $200,000 rather into an annuity with interest compounding monthly. So for question A, for this to take place, what interest rate would allow Joe to withdraw $2,500 each month for 10 years? I'm going to round the answer to one decimal place. So present value is at a negative. He's giving money to the bank and he's at negative $200,000. Now he is doing a compound monthly amount for 10 years, and what we're trying to look for is what the interest rate is. So he's making 120 iterations or 120 payments is going to be happening, Now he is withdrawing money. He's taking money away. So the payments that are being given to him is positive because there's money going into his pocket, and he's taking out $2,500. Now he wants to know, how long is this going to last for? So technically it should say until finished, because some people might misinterpret this information and think that this is perpetuity, where the amount of interest that has been provided to him is the same amount of keeping that $200,000 at that same spot. And we don't want that. We want this to just keep going down until it hits zero. Our future value in this case is zero, with 12 and 12, the compounds and the payments. And what it's spitting out is this particular interest rate. So this amount here, you will get 8.68922416. So therefore, interest rate of 8.7% per annum. It's asking for one decimal place. Now B, it's saying assume that the interest rate is 5% now per annum. So we're not dealing with this 8.7, we're dealing with 5% per annum. And Joe receives a higher regular monthly payment of $3,000. So he's withdrawing more. How many months will this last? So let's put in the information we do know. Present value, 200,000. He's getting $3,000 per month. He wants to see how long this will take until the future value is at zero. The 12 compounds, 12 payments. And the interest rate is locked in at 5. How long is this going to take? 78.26397.5 months. So therefore, it will take 78 months. We are going to round down in this case. We're going to round down because we don't want to round up to 79 months. We just want to play it safe and go 78 months. This is also the same as 6.5 years. Oops. Now we've got one more example. Not one more example, two more questions for example 24. I'll just make a new page for this. All right. Question C, assume that the interest rate is 5% per annum, just like the previous one, and that Joe wishes to be paid monthly for now 10 years. So 6.5 years, it's not going to cut it for Joe. We want this for 10 years. How much will his regular payments be? It's a bit of a tongue twister. So we want to know how much is he allowed to take out. So again, we have got 10 years, so 120 payments, a 5% rate, with an investment of $200,000, so it's negative. Future value is 0 with 12 and 12. How much is allowed to make? When you work this out, this will be 2121.3103. Therefore, in receive or withdraw, I prefer E, let's have to see, $2121.31 per month. So question C. All right, last one, and then you guys can get started on these. Say questions. If Joe receives the regular monthly payments found in Part C for 119 months, what will his final repayment be? Round your answer to the nearest percent. So let's assume that he's doing 120 payments, 5% minus 200,000. Now he's putting this amount into taking this out, so it's positive, so it's going into his pocket. And what we're trying to look for is what this future value will be. When you put these amounts in, you will get 0.047, or a measly 5 cents. So his final payment will be whatever his usual payments are, plus 5 cents. So this will equal 2121.36. All right, trying to make sure that this is under 15 minutes. Yep. And those are your questions there. Questions one of each example, and if you want to do 2 of each example, you're more than welcome to, if you have plenty of time for work. Best of luck with this. This is the last exercise until I sack. So have fun, good luck. Bye.